Hi, we're back. Logi's with me here today.
Mm-hmm.
We're going to be graphing some quadratic functions today, Logan.
You know, we are doing that. I'm gonna eat my precious donut.
Okay, we'll do that. So in your notes, you should see a pretty large and in-charge chart, and it reads like columns. So we have standard form, we have vertex form, and we have intercept form. And it's going to read down the column for like instructions, step 1, step 2, and there's even some tech tips at the bottom of it, I believe, how you can use your graphing calculator. In my lesson today, I'm going to be using a TI-84, my emulator, the same thing you guys can get on your Chromebooks. But you can also be using your own personal calculator that graphs, any variety of it, or Desmos is a really great program that has a nice graphing calculator component to it. So, standard form looks like this. It is general form for a quadratic, and then we have vertex form, named very aptly because you can see the vertex, and then intercept form, also known as factored form, looks like this, called intercept form because you can easily identify your two x-intercepts of your quadratic. So there's the chart I'm referring to. It's got a lot of info on it, and again, it reads down the columns. Tech hints are at the bottom. Let's dive in. Standard form. So standard form is in the form y equals, or f of x equals ax squared plus bx plus c. And one of the formulas that we're going to be using quite a bit is the axis of symmetry formula, which is this guy right here, x equals negative b over 2a. That identifies the line that'll slice your parabola right in half, which is very important because these are so symmetrical. So that's the first thing I actually would like to find, is the axis of symmetry using that formula. Now, a and b and c, remember, are the coefficients to your function. So a is this guy here, this 2, and then b is this middle coefficient, so in our case it's a negative 4. So using my axis of symmetry formula, which is x equals negative b over 2a, we read that as negative b meaning opposite of b. So the opposite of your b term would be a positive 4. And then we're going to divide it by 2 times a. So 2 times a, remember, was a 2. Now, those of you who are very happy to type on your calculator, just remember that you'd have to put grouping of parentheses down there in the denominator. But in our heads, I think we can calculate this, Logan.
That's weird. Why can you do like a number and a letter together?
That is the mystery of algebra, is it not? Logan, do you know what 2 times 2 is?
2 times 2. I kind of forgot.
It's 2 plus 2, if that helps you any. Same thing.
4.
It's 4. All right, so 4 divided by 4 means we just got an axis of symmetry of x equals 1. So something unusual about the axis of symmetry is not only is it a line that cuts the parabola in half, but that number that you just got, the x equals 1, is also the x value of your vertex. So what I'm going to do, maybe I should use red here, I'm going to draw a red line through x equals 1 on my graph. That's really not straight. Ooh, bad graph. Okay. And notice my vertex is going to be somewhere on this line. It's supposed to be at 1. I apologize, but I'm going to make this a red 1 now. So here's where, if you want to be reliant on your technology, which is totally fine, this would be a good moment to step away from the paper and go to your calculator. So I need to remember what our formula is. 2x squared minus 4x plus 3. All right, Logie, we got to remember that. 2x squared. So I'm in y equals, by the way. 2x squared minus 4x plus 3 was the end.
Mm-hmm.
So if you want to see a picture of it, there he be. Remember that x equals 1 is the line that's going to slice through the center of your parabola, which it did.
The only thing I'll remember is that V.
It doesn't. It's a U shape. V is a totally different graph.
That looks like a V more than a U.
Okay. So if I just went to my table, I went to second graph. And look at where x equals 1 is. You have this other part of the ordered pair. Apparently y is also 1. But what I want to point out to you is the symmetry. Look at this table. Surrounding the x equals 1, which we know is going to be the vertex, you have these symmetrical points where it gives you the same y value, a 3 and another 3. So if you can spot the symmetry on your table, that's another way to find the vertex. Sometimes the vertex is not at an integer, so you got to be a little creative. Whoops, that's not an eraser. You got to be a little creative, but those are actually the ordered pairs that I'm going to steal right now. So on my table, I saw that the vertex was at 1, 1, and then right above that in the table, we had an ordered pair at 0, 3, And then the one below it, I believe, was 2, 3. So those are the 3 points that I can plot. 1, 1 is my vertex, 0, 3, and 2, 3. Okay, this was supposed to be symmetrical, right? And then Logan's right. This shape is a little strange. Quadratics, known as parabola, they're supposed to be U-shaped. Mine does not look U-shaped at all.
This is like a tiny donut.
The donut looks more quadratic than my quadratic. You're right, you're right. All right, so that is supposed to be a parabola. All right, standard form, not the greatest. Axis of symmetry, The reason we're showing you the calculation for axis of symmetry is because there is going to be a time in your life, the SAT, where you are going to be given a question like this without the assistance of a calculator. So you have to know how to find that center point using the axis of symmetry formula. So once again, I'm going to use the axis of symmetry formula, which was negative b over 2a. And then this time, be careful, the b value, there is a number in front of this x. There's an invisible 1. And then the b value, I think I messed up my colors just now.
That's cheating. No invisible.
There's a lot of things invisible in math. Sorry.
No cheating.
Not cheating.
Yes, cheating. No invisible stuff.
All right, so the opposite of our b term would be a negative 1. And then we're going to divide that by, careful here, 2 times the a value, which is a negative 1/2, I believe. So again, people who like to use their calculators are going to need to remember to group that denominator in parentheses. And I'm going to, that's supposed to be an arrow. Man, I'm a hot mess today. So this becomes x equals, this is negative 1 over negative 1, which ends up being a positive 1. Now this is interesting. We got 2 axes of symmetries at x equals 1. It won't always happen that way. So don't think your axis of symmetry is always going to be at 1. Oh, gosh, it's ugly. Okay. So I'm going to go to my calculator right now because I do get to use my calculator. And I'm going to type in my new function, which I already forgot what it was. I think it was a negative 1/2 x squared plus x, and I don't remember the constant. What was the c value? Plus 4. So again, you can peek at the graph if you want. Ooh, what do you notice about that one? That's different.
N.
This looks like an N. Okay. Or an upside down U.
Nope. Pyramid.
Pyramid. Why don't you go ahead and chew that donut? All right. So if I go to my table, we already know that that center, that symmetry piece is going to be at x equals 1. So let's check out the table one more time. So surrounding x equals 1, which is our vertex, you're going to see that symmetry that we're looking for right around it. Perfect. Can you remember these numbers for me, Logan? 4, 4.5?
4.5.
4 and 4.5. Okay?
4.5.
Okay. It was 0 and 1 and 2. And the numbers were 4
4.5.
and 4.5. All right. And then we got symmetrical points, so that one's a 4 as well. So the axis of symmetry indicates where the center was, which means you know where your vertex was. Now you might be asking yourself, well, that's great. You used a calculator, you cheater. How would you find the other part of the vertex if you didn't have the calculator to look for the symmetry? Well, that part's not great. You would go back to the formula and you'd plug in a 1 for all of your x's, which without a calculator isn't awesome, but it's totally something we could do if we had to do it.
It's very awesome.
It's very awesome.
I can't do this.
Sure you can.
No, I can't.
1 squared is 1. 1 times negative 1/2. You don't need to know that.
Like in
Not till
15
later.
years.
15 years. I think you'd surprise yourself. So let's see here. We got a 5, but then we're taking away a 1/2, and that's where they're getting that 4.5. So what you just found was the y value to the vertex. So that's how you could find the y value if you had to do it by hand. Am I going to make you do it by hand? Not for this class, but oops, I didn't graph it. For the SAT as a whole, you need to make sure you can do this by hand. And I'm just going to ruin everything by trying to graph it. One thing you might notice, to carry on some old information from our previous lessons, this parabola is reflected over the x-axis, and it seems to, and the negative in front of it is why it reflected, right? The negative in front. It also seems to be a little wider than the last one we graphed, and that's because the a value in front is a 1/2. So you have this vertical contraction that's happening. We'll talk more about those transformations again. right now when we get to vertex form. So vertex form is way better than standard form because you don't have to calculate anything to find the vertex. You can just look and you can see the vertex from the formula. So remember, anything in math in parentheses like this probably has a built-in negative, which we have here. So the vertex is located at h, comma k. Built-in negative on the h, so we got to think opposites. Now the axis of symmetry, since we know the vertex, we can just say it's at x equals h. There's no calculations that have to happen. So watch how nice this is. Yes, what's up? No, you're waiting for the magic to happen? Okay, okay. So this guy right here, remember that's h. And this guy right here, this is k. So the axis of symmetry by that last screen said it's at x equals h. So that means we're at x equals 4. The vertex is located at h comma k. So for us, that would be 4 comma 3. And if you don't believe me, you could have graphed this on your calculator and saw the symmetry on your graph and on your table. So let's go ahead and do that. We have x minus 4 squared plus 3. Can you remember that for me?
Does like every single video have to be with like X and Y?
There's a lot of x and y in math, yes. But sometimes we get crazy and we use a z. Now, we thought the vertex was at 4, 3. Let's see. Here's 4, 3. And I'll notice if I look around the 4, 3, yep, we see that symmetry that we're looking for. So we did good. All right, can you remember 4, 3, 4 for me?
4, 3, 4, okay.
4, 3, 4, 4, 3, 4. All right.
4, 3, 4.
4, 3, 4. So basically, I'm just copying the ordered pairs, that chunk of the table, over to my my paper here. And then I'm supposed to plot this, which this is where it's going to go poorly, but that's okay. So we've got 3, 4. We've got 4, 3. And we've got 5, 4. And then we create this parabola. And the other thing I would love to see on everyone's parabola is a really poorly graphed axis of symmetry line. Remember, this guy was at x equals 4. And it should make sense. Even if you graph cruddy like I do, you should see this split of the parabola through the line x equals 4. All right, so far so good. Let's look at this guy. So I actually like to identify the vertex first on vertex form. Makes sense. Be careful on this one though, because remember there is a built-in negative here. So this parenthesis set really says x minus a negative 3. That's how it changed to a positive 3. Am I boring you, Logan? No, that's all right. So the vertex is at negative 3, comma 7. I'm going to go ahead and throw that on my table because I know it goes right there. And then now I can clearly see the axis of symmetry would be at, remember the formula was x equals h. This is our h, right? So x equals negative 3. We'll worry about that graph later. I tend to do better on axis of symmetry if I graph it after I graph the parabola. All right, we got to remember this formula. Negative 2, x plus 3 squared plus 7. Bless you. I'm going to insert...
What was it again?
Negative 2.
2.
I deleted my parentheses. Sometimes it's just not worth it to insert, guys. All right, it was...
Negative 2.
I forgot.
Something.
X plus 3 squared plus 7. So x plus 3. Don't move my microphone. All right, x plus 3 squared plus 7. Now, if you didn't have a calculator, you would obviously choose symmetrical points for the table. Let's actually do that for a moment. Let's see. So if I chose a point before and after negative 3, the point before it would be x equals negative 4, and then negative 2 would be after it. You would have to manually plug those into the function. And since we know they're supposed to be symmetrical, technically you can just plug in one of them. It's a little risky though, because if you screwed up on something, you wouldn't catch your mistake. But if I took the formula, negative 2, and then it's x plus 3 squared plus 7. And then I went and I plugged in, it doesn't matter, I'm going to plug in the x equals negative 2 right here. Now, doing this in your head, you got to be careful. You got to do order of operations. So you do parentheses first. Negative 2 plus 3 is 1. 1 squared is 1. Negative 2 times 1 is negative 2. And then if we were to add 7 to that, we'd get a 5. So what you just found is the y value of this ordered pair, which better match the y value to this ordered pair because of the symmetry. Now, since I do have a calculator, let's go to our table and see if that worked out. That's not an eraser, Mrs. Abruzzo. Okay, so it was at -3.7. Oh, looky there, right around it. We got the symmetry of the 5s. Yeah.
Ooh.
Ooh, no, I did good.
No.
Yeah.
No, you didn't.
Tough crowd. All right, -4, 5. And then -3, 7. And -2, 5. It's getting a little weird here.
I think you're having a little struggle.
A little struggle.
Maybe you should learn math a little more.
You turd. All right, this is not straight either. All right, you know, my confidence is dashed. That's okay, though. All right, there's a parabola. If we have to do it without a calculator, we can. Do we want to do it without a calculator? Nah, not really. So intercept form. Intercept form is also known as factored form because you have your quadratic setup already what we call factored. So the intercepts would be where it crosses the x-axis, and what you do is you set each of your factors equal to 0 and you solve them. This is actually an upcoming lesson for us. So the first x-intercept would be if you took x plus 3 and you set it equal to 0. Well, that would give you x equals -3. So we're going to plot the ordered pair -3, 0, which is right here on the x-axis. And then same idea, you would take x minus 5 and set it equal to 0 and solve that equation. So you get x equals 5. So I have 2 points, and they are symmetrical, which means the dead center of those intercepts would be where your axis of symmetry is, and that's where this formula is coming up today. This is a different way of finding axis of symmetry if you know the factors or the intercepts. So P and Q are those 2 intercepts that you just found. So I'm going to use that formula that we just talked about, and I'm going to take P plus Q divided by 2.
Divided by 2?
Yeah. So if I simplified that, and again, if you're on a calculator, make sure you're using parentheses right here. That is 2 over 2. Oh, we have another axis of symmetry at x equals 1. I don't know why they keep coming out to x equals, not all of them, but you know, today a lot. So once again, I could graph a really horrible dotted line. Oh gosh. At x equals 1. And normally I'd be giving up right now, but I think this one goes way far down.
How far?
Well, judging...
To the bottom of the earth?
To the bottom of that graph, I bet. All right, let's see. So we know now, because of the axis of symmetry, that the vertex has an x value of that same number. So I know the vertex has an x equals 1. And to find the y value, again, I could grab my calculator, but it really wouldn't be that hard to plug in x equals 1 into my formula from the beginning.
You need your calculator?
Not today. All right, so 1 plus 3 times 1 minus 5 would be a way for us to find the y value. And if I was a good teacher, I would have put better colors here. This is a 1 in red. So calculating that, this is a 4 times a -4. You don't need to know that because you're only 7. But it's a -16. So we just found out that the y value to this vertex is at -16. That's why my teacher made it go down so far. So there's the vertex. All right, there is no chance I'm going to graph this nicely, Logan. I'm going to try, though.
Graph it nicely. No,
oh,
graph it nicely.
I tried. I panicked.
Nice.
I mean, it doesn't look bad. The problem is I didn't hit the point I was supposed to hit.
I think I can do it.
Probably. All right. Moving along here. Now notice I haven't touched my calculator on that problem. I actually think it's easier not to touch your calculator on intercept problems, but that's just me. So intercepts. The 2 in front is going to be one of these vertical stretches. It's going to stretch it by 2. It's not going to affect your intercepts, though. So if you were to take these factors and set them equal to 0. So again, you've got this x minus 3 equals 0, and you've got this x plus 1 equals 0. Hey, Log, this is our last problem. Let's make it really, really good, okay? So this one would give you x equals 3. So that's an intercept at 3, 0.
3, 0, 3, 0, 0.
And then this one, if you subtract it over, you'd get a -1, 0. Now, I haven't done a good job of explaining this part, but an x-intercept always has a y value of 0. That's why I'm finishing off those ordered pairs with zeros. Sorry about that. Okay, axis of symmetry formula. We're supposed to use this p plus q divided by 2 thing. All right, so that becomes 3 plus -1. You'll never guess what happens, Logan. It comes out to 2 over 2, which is 1 again. Why did I do this? I swear to you, they're not always x equals 1, guys. All right. So as far as my vertex goes, the only thing I know for sure is that the x value of my vertex is a 1. So now I'm going to go back to my formula, the whole formula here. And I'm going to write down y equals 2. And then instead of all the x's, I'm going to plug in the 1 that I just found for all the x's. So that would be a 1 minus 3 and a 1 plus 1. All right, we got this. Ready? 2 times -2 times 2. That's -8. We just found out that y equals -8. That's the other part of our vertex. I didn't graph the other point. Oh, for Pete's sake. All right, -1, 0 was the other intercept. And then 1, -8 down here was our vertex. And I'm supposed to be able to create this parabola. Oh, gosh. I've lost the child. Okay, this is like the world's ugliest parabola. You know what would make it uglier? If I drew in the axis of symmetry. Yep, that sure did do it. That is one ugly graph. Okay, so y'all are going to be using technology to assist you here. I'm going to work on my graphing. Logan's going to give me a little training session on how to do art.
He likes to bite your hair.
Yeah. All right, good luck, everybody.